Next, I want to talk about plate tectonics. So tectonic forces are forces that move or deform and break the Earth's crust. And plate tectonics is about the Earth being broken into different segments called plates. These are moved around by on top of the soft or asthenosphere. So these are the plates that the lithosphere is broken up into. Many of them correspond to continents, such as the North American plate or South American plate. Europe and Asia together make the Eurasian plate or the African plate. Some are smaller ones, like this one called the Juan de Fuca plate or the Cocos plate. They are remnants of an older plate that has since kind of been pushed under North America. And then there's this one here, the Pacific plate underneath the Pacific Ocean, and a few other ones like the Caribbean plate. Here's another color-coded illustration to kind of show you where many of these plates are. And so the outer layer of the Earth is broken into these different plates. These are the major ones. And where those plates meet up with each other, there's three types of boundaries. In some places, the plates are being pulled apart. They're what's called a divergent boundary. So here, this is in the middle of the Atlantic Ocean. The tectonic plates are being pushed apart from each other. In some places, they're being pushed together. So either in the ocean or from the ocean and continent, either the ocean is being kind of shoved into the continent or two pieces of oceanic crust are being pushed together. That's called a convergent boundary. And then lastly, like here along the San Andreas Fault, we have what's called a transform boundary. These are not as common, and these are places where one piece of the Earth's crust is sliding past another. So with convergent boundaries, the plates collide, and these are what we call destructive boundaries, because as they collide, material is being shoved underneath one of the continents and disappearing. We can divide these into three general types. One is oceanic to continental, where the oceanic crust is being pushed underneath a continent. And two other types include, this is the one that we look at most, that this is the one that really creates a lot of the landscapes or mountainous and volcano areas that we see on the Earth. Now there are other examples like oceanic to oceanic, where one piece of the ocean is subducts within the other. Subduction meaning one gets shoved underneath. And then lastly, there's continental to continental collisions. And these are places where two pieces of continental crust are colliding with each other. So in oceanic continental, you have a process called subduction. And because the oceanic crust is denser and heavier, it subducts or ducks under the continent. And this results in a number of other processes as well. There's earthquakes as this happens. There is melting of the oceanic plate. The melting causes magma to rise and creates chains of volcanoes and creates mountain ranges as well. Another thing that happens in the ocean is you get an offshore trench. And lastly, one thing that happens is that material can be kind of scraped up during this processes. We'll talk more about that later. So this is a model of a place like early California, where you have the Pacific Ocean coming in, subducting underneath North America. You have what's called an accretionary wedge of material being scraped up. You have the oceanic plate ducking under North America, and that's melting magma and creating volcanoes, creating many of the features that we have in California today. So even if we don't have this process happening in some places, it could have happened in the past, creating mountain ranges like the Sierra Nevada. In Northern California, we still have subduction taking place. So you have, let me kind of go back just a bit. So up here, this is called the Juan de Fuca plate, where you have subduction happening because this little plate is colliding with North America. South of that, it's going to be different. This is the San Andreas Fault, which is, rather than colliding with each other, they're sliding past each other. So here, this is the Juan de Fuca plate. It's being subducted underneath Northern California and the Pacific Northwest. That's what creates a lot of the volcanoes like Mount Lassen, Mount Hood, and so on up in the Pacific Northwest, including in Northern California, like Mount Shasta and Mount Lassen. Now, below that in California, this is where we had the subduction and the volcanoes and so on, but below that, we have a transform boundary. This is where plates slide past each other. These can create long fractures in the Earth's surface, as in this example, the Pacific plate is moving northward relative to the North American plate. So in California, the coastal part, at least southern coastal part of California, is actually on a different tectonic plate than the rest of California. This part down here is on the Pacific plate. The rest of California is on the North American plate. And this piece of California is slowly moving northward, little bit at a time, about the rate of fingernail growth. However, pressure can build up along that zone, and you can have a sudden snap and an earthquake as this thing moves along. So here, this is a model of California. We have the North American plate on one side and the Pacific plates creeping northward on the other. Where you have a lot of tectonic activity is an area around the Pacific Ocean called the Pacific Ring of Fire. This is an area that has the greatest collection of destructive earthquakes and volcanoes because of all of the subduction and other tectonic processes that are happening around the Pacific Ocean. One last concept is something called accretion or accreted terrains. So as subduction is happening, material can be accreted or pushed up onto the edge of a continent. Over time, that can slowly fuse with the continent, creating new sort of new types of mountain ranges that are not maybe as big as the volcanic peaks, such as the coast ranges of California. So much of the west coast of North America has been created by accretion. So over time, as islands kind of get dragged up into the continent, they can be welded or fused onto the continent, creating more land. Now, one example of where we can see this is what's called the Franciscan Complex along coastal California. This is a collection of material called melange, and melange is accreted material of different types of rocks that have been fused onto the continent here. They're often a mix of different types of material that's been kind of dragged along and then welded onto the continent over time. So here, this is an island arc. It gets pushed along, it gets closer and closer, and then if suddenly it's kind of shoved and then squished onto the continent. And so back into this model of early California, not only do you have subduction happening in volcanoes, but you also have accretion happening. And accretion creates this San Franciscan complex or melange along the edge of the continent.